Hello friends, now we will start with the next topic of feedback amplifiers, that is current series feedback amplifier using BJT. You can see the circuit drawn on the right hand side, that is the circuit of current series feedback amplifier. Remember, for analysis of a current series feedback amplifier, we need to follow certain steps. The very first step is we need to identify the topology of the feedback, the type of feedback. The name itself is clear that it is a current series feedback. We will see how it is current series feedback. 2, we need to find the factor beta, that is feedback factor beta for this circuit. 3rd, we need to identify the input and output circuits without feedback loading. In this circuit, we will be finding input and output circuits without feedback loading. Fine. And last one, we need to draw the small signal equivalent circuit without feedback loading. We will see how to do that. Fine. Let us see this circuit first. Let us classify this circuit into current series feedback. Here, this is the load circuit. Output terminal is the collector terminal from where we are taking output voltage. The load is connected in the collector circuit, so the collector current is equal to the load current. Remember, this load current flows from the BJT towards your load resistance. This is load resistance RL, and output resistance will be flowing from collector terminal towards this, and that is equal to minus IC, minus of collector current. Fine, minus IC. So output current is minus IC. We are saying current series feedback. When you say current series feedback, that means output signal here is taken to be current, not the voltage. I repeat, the output signal of this circuit is considered to be current. In current series feedback, this is the output signal and this is the type of mixing. So we have series type of mixing. Series type of mixing is voltage mixing. So we have current as the output signal and voltage as the input signal, because when there is voltage mixing, so that indicates voltage is the input signal. So in the amplifier where input signal is voltage and output signal is current, that amplifier is transconductance amplifier. So this circuit is being used as transconductance amplifier. Fine. So transconductance gain will be the output current, that will be the ratio of output current to the input voltage. Fine. So we will see one by one. So when your output signal is current and I need to take current sampling, I am taking current sampling. So that current has to be converted to voltage for series mixing. So in input circuit, that should appear as a voltage. So you see the circuit, this base emitter circuit is input circuit of any amplifier, and collector to emitter circuit is output circuit of the amplifier. Fine. So here you can see that output current which flows into the load from the output terminal, which is collector terminal, this is load, so output current will be flowing into the load. So here that output current will be entering into the emitter terminal because that is going upward, right? So the voltage here, you see it carefully, the voltage due to output current is this voltage, and that is the feedback voltage, right? So that will be the feedback voltage in this circuit, and that will be definitely equal to what? You can see that the feedback voltage here. Now the point is, if you see, this voltage is additive, but for negative feedback what should be there? This voltage minus plus, this is additive to supply voltage, so feedback becomes positive. So if you take plus minus like that, in that case it becomes negative feedback. So we need to remember, if you remember the block diagram, we have plus sign here, a minus sign here. This is input signal Vs, this is feedback voltage Vf, and we must take polarity of VF, which is nothing but Vs minus Vf. The polarity of Vf must be negative. So for Vf to be negative, so if it is minus plus like this, and if you move in this direction, so it should become plus minus. So Vf should oppose the supply voltage for negative feedback. But here, if you see, Vf is equal to what? Current I naught is going upward. If current I naught is going upward, so this end becomes plus, this end becomes minus. So current Vf will be equal to minus I naught. Why I am taking I naught? Please see it. Here, what is the base current? IB. Here, what is the collector current? IC. Sorry, IE. Here, what is the collector current which is going downward? IC. So, emitter current IE is equal to what? I naught plus IB. But you know, the base current is very small. If your base current is in microamperes, then emitter and collector current are in milliamperes. So, I naught is approximately equal to IC, and that is equal to minus I naught. Why? Because I naught is entering into the load. If it is load, so it must go enter into the load from the output terminal. So Vf is equal to what? That is IE into Re, or that is minus I naught into Re, right? This is output signal, this is feedback signal. Beta is what? The feedback voltage by output current, and that is equal to minus Re. So feedback factor beta here is minus Re. Resistance, emitter resistance. Re is what? Emitter resistance, right? So this is beta. Voltage series feedback, name itself indicates. So we are using this circuit as the transconductance amplifier. That is important point you should remember. Now we need to find the input and output resistances of this circuit. And input and output resistance and voltage gain of this circuit, but that has to be identified, that has to be obtained without feedback loading. So I need to identify the input and output circuits without feedback loading. Let us see the diagram, and then we will try to visualize what to do for identification of feedback circuit. This is general diagram of a feedback amplifier. It is like this, it is like this, it is like this, it is like this. What is the type of sampling? That is current sampling here. Why? Because output signal is current. This is current. So current sampling is also known as series sampling. Voltage sampling is known as shunt sampling. So that means for series sampling, if it is the load current RL, it should be connected in series like this. So output current flows like this, flows through RL, goes to this circuit and comes back like this. So output current passes through the circuit, feedback circuit. Fine. Now it is voltage series. Output current, output signal is this current which is series sampling, and input is series mixing, and on input side series word stands for the feedback voltage, like that. This is resistance Rs, this is Vs minus plus, like this. So I have series sampling like this. Series sampling, sorry, series mixing and series sampling. Series sampling is known as current sampling and series mixing is known as voltage mixing. If you are getting confused, see my first video on these nomenclatures. Rather than second video of this chapter on YouTube, you can refer that video. Fine. Now, I need to identify the circuit from this side. When this current through this is 0, the current should not flow into this circuit. In case of series, that current will come like this and passes through this like this. So that current should become 0, and that current becomes 0 when this is open circuit. So In has to be set to be 0. Input current has to be set to 0, so that there is no current and there is no loading of the feedback network from the input side. Similarly, for identification of input circuit without feedback loading, this has to be set to 0, so that no current flows from the output side into the feedback network. So feedback network should not be drawing any current. So it should not be drawing any current, means I have to put current equal to 0 on both sides. If I have to identify the output circuit without feedback loading, put I in equal to 0, and if I have to identify input circuit without feedback loading, put I not equal to 0. That is for this current series feedback. Now let us come back to your circuit. You won't find this thing explained in the book directly, so you should remember this concept. Theoretically it is given, of course, but diagrammatically it won't be explained in the books, textbooks. Fine. Now come back to this circuit. So what is output terminal? This. So for identification of input circuit without feedback loading, I need to set I output equal to 0. That means this current has to be set to equal to 0. And current on the output side can become 0 if and only if this is removed. That is open circuit. Load is removed. When this load is removed, you can see this is the base current. Current going that side is 0. So what will be current here? Current here will be again 0. Current in RE will be 0. Current in RE not 0, rather current will RE will be IB here when this is 0, IE 0, right? So this is RE. So VS will be equal to IB RS plus IB RE and plus VBE. This is voltage VBE. Fine. That means this RE is appearing in the input circuit, or if you apply KVL here, plus minus plus rise, then it will be plus, it will be minus, so it will be minus, it will be minus, it will be minus, that is equal to 0. That is also correct. Fine. So that means if I am multiplying this RE and RS by base current, so I can take it this, like this. So that means this RE can be taken on input side, like this, right? If this terminal was X, this was Y, so this terminal is X, this terminal is Y. Fine. So this circuit is input circuit without feedback loading, like that. Fine. Because it is involving only base current, it is not involving output current. So that circuit is known as, it is involving only base current, input current, not the output current. So that is input circuit seen by the voltage source on input side. That is known as input circuit without feedback loading. I hope it is clear. Now for identification of output circuit without feedback loading, what do we need to do? Put I in equal to 0. So when you put I in is equal to 0, I will again now take output circuit without feedback loading. So I connect it here again. Fine. So for identification of output circuit without feedback loading, I need to put input current I in equal to 0. I have already explained that. Fine. So when you put I in equal to 0, current 0 means open circuit. So that means this has to be removed, this has to be replaced by the open circuit. Only then input current can be 0, only then that base current can be 0. Fine. Base current here is input current. So now, what is the current here? I naught. What is the current here? I naught. Fine. This is equal to what? Minus IC. This is equal to what? Minus IE or IC itself, because base current is 0. Fine. So if this terminal is X, this terminal is Y, so you can replace this voltage source by this, like this. That's also correct. Either you put a potential at a point or you connect a battery between that point and ground, that is same thing. So now the output current is flowing this way. So when you connect battery instead of this point, so what do we find? We find this is open circuit, so only current passing through this resistance RE is now I naught, because I in is 0. So I can take this resistance on output side with this terminal Y, this terminal X. This is feedback voltage. Fine. Here this terminal was X, this was Y. So now I will be connecting both circuits without feedback loading. For input circuit without feedback loading, I have RE here. For output circuit without feedback loading, I have RE here, and that is removed from the feedback part. This is the only part which is common between output and input. So you have removed that part, and this is the output circuit without feedback loading, and this is the input circuit without feedback loading. So this is all about your circuit without feedback loading. Fine. So what we have done, that resistance which was connected in RE, that comes in input circuit for identification of input circuit without feedback loading, that goes to output circuit without feedback loading. So that is totally in the output circuit. So nothing is there between, which is common between input and output circuits. Fine. So this circuit is known as the circuit of the amplifier without feedback loading. Fine. So for analysis of this amplifier, now I need to replace BJT by its small signal model, and BJT has got different models. It can be approximate H parameter model, it can be pi model, it can be small RE, that is RE model. So it is your choice. You can replace BJT by its model, any of its model. In my case, I will be replacing it by approximate H parameter model, but it can be replaced by any of its model. That may be pi model, that may be RE model, that may be approximate H parameter model. So for small signal analysis, we replace the BJT by its approximate H parameter model in our case. Fine. So when you replace BJT by its approximate H parameter model, so on input side we have a resistance which is HIE. Fine. On output side we have a current source. That current source is, this is base current IB. So this is HFE into IB. Fine. That's it. This is terminal E, and that voltage source, biasing source, should be replaced by the ground. This is the output terminal V0. This is output current I0. Fine. Right? And this is ground, of course. This is ground. Right? Y terminal of the transistor resistor is ground. So output voltage is between this and this voltage across. This is output voltage, like this. This voltage is output voltage. Voltage between terminal C, this is terminal base of the transistor, this is E. So voltage between C and ground is output voltage, right? I hope it's clear. Now let us proceed further. In this case, what is the output signal? Current. What is the input signal? Voltage, because we are talking about transconductance amplifier, because in current series feedback amplifier, output signal is current, input signal is voltage in this amplifier. So output signal is considered to be I0, not V0, right? Output signal is considered to be I0. Fine. Now, so output signal is I0, that is I0 is equal to what? Minus HFE into IB, right? What is the base current here? You can please see, base current is this current, which is the VS divided by RS plus HIE. RS plus HIE. So I0 will be equal to minus HFE into VS divided by RS plus HIE. I hope concept is clear. So what will be the transconductance gain? The transconductance gain, I'm sorry, there is one more resistance here, that is RE as well in this circuit, input circuit. So we have RE also. Fine. So what is the transconductance gain of this? That is I naught upon Vs, that is equal to minus HFE divided by Rs plus HIE plus RE. This is your transconductance gain. So what is desensitivity of the amplifier? 1 plus Gm into beta, that is known as desensitivity. Beta here is what? That is 1 plus Gm is minus HIE divided by Rs plus HIE, this is HFE, HIE plus RE multiplied by beta was what? Minus RE. We have already identified that was minus RE. So this is minus RE. When you multiply it by minus, so that becomes plus. So this is your desensitivity of the amplifier without feedback loading here, of course. Now, what is input resistance without feedback loading? The resistance seen by the source is input resistance. So Ri without feedback loading is Rs plus HIE plus Re. That is input resistance without feedback loading. I hope the concept is clear. Fine. Now let us talk about output resistance without feedback loading. Output resistance is the resistance seen across output terminals R0 when input Vs is set to 0. When you replace input by 0, you can see this circuit carefully. Then base current becomes 0 because there is no source in this circuit. So base current becomes 0. When base current is 0, so this dependent current source becomes 0. And if this current is 0, that means this is open circuit. That's it. So what will be the output resistance? That will be RC itself. So output resistance will be RC. Please remember one thing, one point here. If I am considering RC, so RC can be load resistance. So in that case, it has to be replaced by the open circuit and see from here. R0 is equal to what? R0 is infinite. Load current, remember, for finding the output resistance of a circuit, replace in load resistance by open circuit, replace voltage source by short circuit, input voltage source by short circuit, and if there is input current source, replace that by open circuit. So R0 is infinite, right? But if you consider RC, in that case we are considering that load resistance may be connected separately between output terminal and ground. That is also option. Load may be connected separately. In that case, R0 will be equal to RC. So I am taking R0 equal to RC here. Fine. I am taking R0 equal to RC. Although, I repeat, although R0 itself, if R0 itself is a load, RC itself is a load, in that case R0 will be infinite because RC will be replaced by open circuit. Because load resistance has to be replaced by open circuit for identification of output resistance. Fine. So in some textbook you may be finding that R0 is infinite. That reason for that is R0 is infinite means when load RC itself is a load. So that has to be replaced by open circuit for identification of output resistance. That is why sometimes you are given that your output resistance is infinite. Fine. So, however, for finding out what gain of the amplifier with feedback, GMF is equal to what? GM by 1 plus GM beta, or that is GM by beta. And you know what is GM? You know what is D? Not beta, D. So you can find that expression, gain with feedback. Second, what is input resistance with feedback? Input resistance with feedback, it is current series mixing. So input side it is series mixing, and when there is word series, input resistance increases. So that has to be Ri into 1 plus Gm into beta. And you know Ri, you know 1 plus Gm into beta. Output side is current sampling, and current sampling is series sampling, and wherever there is word series, output resistance increases. So that has to be R0 with feedback is equal to R0 into 1 plus Gm beta. and if R0 is infinite, because if RC is open circuit, so this is RC into 1 plus GM into beta if you are considering this, or this can be infinite if you are replacing RC by open circuit. So in some textbook it may be given to be infinite. In that case, that means RC itself is a load, fine, which is assumed here. So don't get confused. When load is RC itself is a load, in that case you have to take that way, this way. And if our load is connected separately, in that case replace it by open circuit and RC will be taken into account, right? So this is your current series feedback amplifier without feedback loading, fine. So in next video I'll be talking about voltage shunt feedback amplifier. Just wait for my next video. Thank you very much for watching the video.